Hello everyone. In the previous session, I have discussed one of the important theorems, that is Taylor's and Lorentz theorem. Hope so you will practice it. Now in this session, after the theorem, you just put the heading problems. Before that, please copy this. Again, I'm not going to send the notes of this. After writing that theorem, you just write the remarks. That is, these two are formula to find the radius of convergence. So in almost all the problems that I'm going to discuss in this session, I'll be using these two formulas. So after, I'm just repeating once again, after completing Taylor's theorem and Lorentz theorem, you just put the heading remarks and write these two statements and write it all these statements in note. This is basic formula, so you should remember. Anyhow, you are already familiar with this. Just I have written here in order to glance. So whenever you have limit n tending to infinity, 1 plus 1 by power of n whole power of n value should be written as e. And moreover, if 5 factorial can be written as 5 into 4 factorial. So I can write the same as 4 plus 1 factorial as 4 plus 1 into 4 factorial. I can write the same statement something like this. So for generalizing case, I have written n plus 1 factorial as n plus 1 into n factorial. Similarly, 2n plus 2 as, it is very easy to remember. See here, as you expanding the factorial value, the term should go on decreasing. So first term as it is, next decrease one term. So 2n plus 2 minus 1 give you 2n plus 1. Next decrease one term, you will get 2n. So next term will be 2n minus 1. Fine. So this is the concept of factorial notation. Anyhow, you are familiar with this in your first PU. So log 1 value is 0 and log infinity value is infinity. So after that, you just copy this. Next, write down the heading problems and copy these problems. Whatever I am doing in this session, you just copy just by watching the video. Fine. Now we are asked to find the radius of convergence. Here is the question: summation z power of n by n factorial. So as I already said, there are two formulas. So whenever you have usual terms, something like this, you can note difference between these two terms, right? So see here, I have written two problems here. Here clearly z power of n coefficient is 1 by n factorial. Whatever the term associated with z power of n is 1 by n factorial. So you have to take that as an. Here whatever I am going to write the steps, you have to copy the same. Here an is 1 by n factorial. Why? Because it is the coefficient of z power of n. Right? But here you can see that coefficient of z power of n is in terms of again powers of n square. Right? That is powers of n. In such case, you are going to use the second formula. Anyhow, here the coefficient of z power of n is 1 by n factorial. So you have to use the first formula. As per the problems, when you solve more and more problems, you will get an idea. Don't worry about it. So first let me write down the formula. Formula is given by r is equal to limit n tending to infinity an divided by n plus 1. It is suffix. Fine. Anyhow, I have an here. Replace n with n plus 1. So you will get 1 divided by n plus 1 factorial. Fine. Now let me substitute. Limit n tending to infinity. An is 1 divided by n factorial divided by 1 divided by n plus 1 factorial. An plus 1 value. Now on simplification, you get limit n tending to infinity. I can write this as 1 by n factorial into n plus 1 factorial divided by 1. Clear? Now, as I told you earlier, whenever I have n plus 1 factorial, see here I have given one counter example also. So I can write n plus 1 factorial as n plus 1 into n factorial. That is one term decreasing. So I can write this as limit n tending to infinity 1 divided by n factorial into n plus 1 into n factorial divided by 1. Now n factorial get cancelled. So what you left with is limit n tending to infinity n plus 1. Now let me take n as common term. If you take n as common term also, you will get 1 plus 1 by n. Right? So again, you can apply the limit or else you can apply directly. So as n tending to infinity, or let me write the step here. So I'll just take r is equal to, I'll just take n as a common factor. Limit n tending to infinity, n common, so you will get 1 plus 1 by n. Right? So as n tending to infinity, 1 by infinity is 0, 0 plus 1 is 1. Infinity is 1 into 1 is infinity. Therefore, the radius of convergence r is equal to infinity. Clear? We just write one below the other. Fine? Now the second problem. Here, write down an value. An value in the sense coefficient of z power of n. An is equal to 1 plus 1 divided by n whole power of n square. Whatever the value is there associated with z power of n, you have to write the whole value as an. Fine. As I said earlier, whenever you have powers of n square, you have to use the second formula. So that is 1 by r is equal to limit n tending to infinity a n power 1 by n. So let me write the formula. It is given by 1 by r is equal to limit n tending to infinity a n power 1 by n. Fine. So 1 by r is equal to limit n tending to infinity. A n is 1 plus 1 by n power n square whole power 1 by n. So 1 n get cancelled. So what you left with is limit n tending to infinity 1 plus 1 by n whole power of n. Fine. Now let me apply n tending to infinity. That is n value infinity. 1 by infinity is 0. 0 plus 1 is 1. 1 power of n is 1. So the value, instead of that I can write like this. Right, let me write one more step. Limit n tending to infinity 1 plus 1 by n whole power of n. This is what I have. See here, when you apply n tending to infinity, 1 by infinity will be 0. So 1 power of n will be, we cannot predict whether n is 0 or 1, we don't know. So we have a standard formula. As I said, see the note, first point, limit n tending to infinity 1 by 1 plus n power of n is e. So it is of the form, standard form. So 1 by r is equal to e. But we need to calculate r. So let me take reciprocal. So you will get r is equal to e. Therefore the required radius of convergence for the second problem is r is equal to e. Only thing is you have to identify which formula that we need to apply. Hope so it is clear. Now let us look at the third problem. So here is a problem. Here you can clearly note that z power of n coefficient is this value. Here we don't have powers of n. As I said, in the second problem we have powers of n. That is n square. Whatever may be the term, whether it is n square, n cube or n, it doesn't matter. We have powers of n. That is why I have make use of this formula. So whenever you don't have powers of n, directly you can use this formula. Fine. So third problem, let me write the solution. As usual, first step you write the formula. Before that, first step write a n value. Here a n is n plus 1 divided by n plus 2 into n plus 3. Now find out the value of a n plus 1. Just change n to n plus 1. So n plus 1 plus 1. Changing n to n plus 1 plus 2 into n plus 1 plus 3. I am writing steps for one problem. So you will get n plus 2 divided by n plus 3 into n plus 4. Clear? Now let me apply the formula. You have to write the formula. It is given by limit n tending to infinity a n divided by a n plus 1. I am repeating once again. Please, I am not sending the notes of the same material. You have to solve the problems by looking at the video. So limit n tending to infinity. A n value is n plus 1 divided by n plus 2 into n plus 3 divided by a n plus 1. I have to write, let me write one more step, divided by a n plus 1 is n plus 2 divided by n plus 3 into n plus 4. So when you shift the term, you will get limit n tending to infinity n plus 1 divided by n plus 2 into n plus 3. Cross multiply it, you will get n plus 3 into n plus 4 divided by n plus 2. So n plus 3 get cancelled. What you left with? Limit n tending to infinity n plus 1 into n plus 4, this is 4, divided by, this is simple calculation, right, n plus 2 whole square. Now we need to apply n tending to infinity. As you already saw such kind of problems in your UG classes, to apply n tending to infinity we have to take n as a common term. Even though there is no n common term, we have to divide it, right? Again let me take n as common term. So 1 plus 4 divided by n. In the denominator we have square here. So you have to take n square as common term. Remember. Why? Because we have square for it. So when you're going to take n common term, power also comes to there. Now n square with n into n cancels. Right? Now apply n tending to infinity. 1 by infinity is 0. Now I'll just write one more step. When you apply limit, since I am not writing limit here, so meaning is I am applying limit here. 1 by infinity is 0. 0 plus 1 is 1. Now 1 by 1 plus 4 by infinity is 0. 0 plus 1 is 1. Divided by 1 plus 2 by infinity is 0. So 1 plus 0 whole square you will get. So radius of convergence will be 1. Fine. That's the formula and substitution. Before applying the limit, you have to take the common factor. That's all. Hope so it is clear. Right? Now let me solve fourth problem. So here is a fourth problem. As usual, first write down a n value. A n is equal to n factorial square divided by 2n factorial. There is a lot of difference between 2n factorial and 2 into n factorial. This represents 2 into n factorial. Fine. So an is this. Now we clearly there is no power of n for an. Look at the term an. We don't have powers of n. So you have to use the first formula. For that, let me write an plus 1. Replace n with n plus 1. So you will get n plus 1 factorial whole square divided by 2 into n plus 1 factorial. Now write down the formula. R is equal to limit n tending to infinity an divided by an plus 1. Now let me substitute. As limit n tending to infinity, an is n factorial square divided by 2n factorial. When you divide it, the term goes to numerator, right? So I'll just write directly 2 into n plus 1 factorial divided by n plus 1 factorial whole square. Now again we need to apply the properties of factorial, that is n tending to infinity. N factorial I'll just keep as it is. Fine. Divided by 2n factorial also I'll keep as it is. Now I'm going to expand this. So as I said, there is a blind method to remember. So when you're going to expand first term as it is, next you have to decrease one term. So minus 1 plus 1 minus 1 get cancelled. You will get n factorial here. Clear? In the denominator also I can write n plus 1 factorial as n plus 1 into n factorial the whole square, right? Therefore R is equal to limit n tending to infinity. I'll just rearrange the term. See here, I can write this as 2n factorial. Now what I'm going to do is I'll just write first term and then I'll write 2n factorial divided by, I'm going to split the square, so you will get n plus 1 whole square into n factorial square. Now 2n factorial get cancelled. Again which term get cancelled? Clearly n factorial square, right? And one more term is square with this. Now what you left with? R is equal to limit n tending to infinity 1 divided by n plus 1. Fine. So R is equal to as limit n tending to infinity. So when you apply, you can apply n tending to infinity directly. If you want, you can take n also common term. It doesn't matter. So now you apply n tending to infinity. 1 by infinity will be 0. 0 plus 1 is 1. Since you get infinity here, 1 by infinity is, I'll just show you here, 1 divided by infinity into 1 plus 0. Right? You will get 1 divided by infinity 1 plus 0 is 1. So 1 by infinity is 0. Right? So radius of convergence is 0. Definitely you will get one problem based on this concept, but I cannot assure you. I try to solve more number of problems based on this concept, but I cannot assure you the certain problem as an important question. So you have to practice and you should know the method. Hope so this concept is clear. Right? Now let me solve one more problem. So here is a problem. Now you can clearly note that an is log n whole power of n, right? So as I said, when you have powers of n for an, you have to use the second formula, that is 1 by r is equal to, what is the formula? Limit n tending to infinity an power 1 by n. I'm reminding you once again, after writing Taylor's series and Lorentz theorem, you just copy down this. That is, first you put the heading remark and copy down these two problems and write down this note. Afterwards start solving these problems. Fine. Now let me substitute in the formula. You will get 1 by r is equal to limit n tending to infinity. An is log n whole power of n, right? To the power 1 by n. Just I have replaced an. Right, so 1 by n with n get cancelled, so you will get limit n tending to infinity log of n, right? So 1 by r value. Now 1 by 11 n tending to infinity, you will get log infinity. As I said, log infinity value is 0. I'm sorry, log infinity is infinity. Log infinity is infinity. So I can write 1 by r is equal to infinity. Since we need the value of r, so you get reciprocal of that. So you will get 1 by infinity. Take reciprocal. Reciprocal in the sense, for any number 1 by a, reciprocal is a. For any number a, reciprocal is 1 by a. So similarly, I have taken reciprocal. So you get r is 1 by infinity. As you know, 1 by infinity is 0. Therefore, you have to write conclusion for all the problems. I am not writing it. Please make sure that you are writing the, conclusion. Therefore, the radius of convergence is 0. Fine. Here is the next problem. As usual, first extract the value of n. Coefficient of z power of n is 1 by 2 power of n plus 1. right? Anyhow, we don't have whole power, right? So whenever you have for a sequence an, whenever you have powers, something like this, then only you have to choose the second formula. Here we can easily simplify by using the first formula. That is, more the problems you practice, more the idea you will get. So we cannot predict the particular formula. It is just a blind method and it is based on the number of problems you practice. Fine. So replace n with n plus 1, you will get this. Again, I can write this as 2 power of n into 2 plus 1. I have just splitted the powers. Fine. Now let me write down the formula. R is equal to limit n tending to infinity an by an plus 1. Now limit, I am going to substitute limit n tending to infinity. An is 1 by 2 power of n plus 1. Divide, when you are going to divide it, you will get reciprocal, right? 2 power of n into 2 plus 1 divided by 1. I can write this as limit n tending to infinity 2 power of n into 2 plus 1 divided by 2 power of n plus 1. Remember, you cannot cancel 2 power of n here. Fine. Now, in order to simplify, I have to take 2 power of n as common factor. Why? Because we have the same term in the denominator as well. So when you take 2 power of n as common term, you will get 2 plus 1 divided by 2 power of n. And the denominator 2 power of n common, so that you will get 1 plus 1 divided by 2 power of n. Now you can cancel 2 power of n. Now let me apply, first let me write the steps. 2 plus 1 divided by 2 power of n divided by 1 plus 1 divided by 2 power of n. Now apply limit as n tending to infinity. 2 power of infinity will be infinity. So you will get, let me apply limit. So you will get 2 plus 1 by infinity divided by 1 plus, why? Because 2 power of infinity is infinity, right? So our value will be 2 plus 1 by infinity is 0, 1 plus 1 by infinity is 0. So you will get 2 by 1. Therefore, the radius of convergence is 2. Clear? Now let me solve one more problem. So here is the 7th problem. Now you can note that an is of the form x plus iy. That is 3 plus 4i power of n. So whenever you have this, remember you have to, anyhow whatever may be the term here, we have powers of n. So as I said, whenever you have powers of n, you have to use second formula. So let me write the second formula. It is given by 1 by r is equal to limit n tending to infinity an power of 1 by n, right? And moreover, one more thing, that whenever you have a complex number, you have to take magnitude along with the number. Fine. And moreover, magnitude of x plus iy, hope so you remember, it is x square plus y square, as I explained this concept at the beginning session. So I can write 1 by r is equal to limit n tending to infinity. Instead of bracket, you have to take magnitude. Why? Because an is of the form of complex number. So I can write this as 3 plus 4i whole power 1 by n whole power of n. Or else, let me write one more step if you want. So this is an value. An is 3 plus 4i power of n whole power of 1 by n. Right? Now n get cancelled. What you left with? Limit n tending to infinity magnitude of 3 plus 4i. So as I told you, whenever you have magnitude, you can apply the formula. It is given by square root of x square plus y square. So limit n tending to infinity. So square root of 3 square is 9 plus 4 square is 16. Right? So I can write limit n tending to infinity. If you want, you can write one more step here. N tending to infinity, it is square root of 3 square plus 4 square. Now limit, it is square root of 20. So whenever you are going to apply limit for a constant, you can write the constant. Why? Because this term is independent of n. So 1 by r is equal to square root of, it is 25. Square root of 25. So 1 by r is equal to 5. So what is the value of r? Do the cross multiplication. So r value will be 1 by 5. So this is the radius of convergence of a given problem. Remember, whenever you have a complex number, you have to take magnitude for that particular complex number and make use of this formula. Anyhow, when you apply the limit, limit will be independent of n term. So I can write the constant as it is. Hope so it is clear. And one more thing is that you can use the second formula whenever the first one, you cannot solve the problem in first method. Fine. And we cannot predict this method is, this formula is applied for this method. There is no particular, condition to use this formula. So it depends on the problem. Now you can see that In the 8th problem, we have minus 1 power of n into n square. That is, an is equal to minus 1 power of n by n square. We can solve this problem in first method. If you want, I'll show you here. An plus 1 is equal to minus 1 power of n plus 1 divided by n plus 1 the whole square. So, write down the first formula. R is equal to limit n tending to infinity an divided by n plus 1. Now, let me substitute. Limit n tending to infinity, an is minus 1 power of n divided by n square. I'll just reverse it. If you want, you can substitute in one more step. Minus 1 power of n plus 1. Fine. Now, let me split the denominator. So, I can write this as limit n tending to infinity minus 1 power of n by n square into n plus 1 whole square divided by, this term can be written as minus 1 power of n into minus 1 power of 1. Anyhow, minus 1 power of 1 you can write as it is. Now, minus 1 power of n minus 1 power of n get cancelled. Now, I can write this as limit n tending to infinity. What is the left out term? N plus 1 whole square divided by n square. You have minus along with it. Now, r is equal to, I can write this as limit n tending to infinity. Let me take n as common term. Since you have square, you cannot take n, you have to take n square. So, you will get 1 plus 1 by n whole square divided by, in the denominator also, I'll take n square as a common term. There is nothing to take common, so you can keep as it is. Now, n square in numerator and denominator get cancelled. So, what you left with is limit n tending to infinity minus 1 plus 1 by n whole square. Now, you apply n tending to infinity, you will get 1 by infinity is 0. 1 plus 0 is 1. 1 square is 1. But you will get minus 1 here. See here, limit n tending to infinity minus 1 you will get. Anyhow, it is independent of n, so I can write r is equal to minus 1. But radius is always positive quantity, so you are going to change minus 1 to plus 1. So, plus 1 is the required radius of convergence. Now, let me solve the 9th problem. So, clearly here an is n cube. That is coefficient of z power of n. Now, let me calculate an plus 1. It is given by n plus 1 whole cube. Now, write down the formula. R is equal to limit n tending to infinity an divided by an plus 1. Now, substitute the terms. Limit n tending to infinity. An is n cube divided by an plus 1 is n plus 1 whole cube. Now, let me simplify this. Limit n tending to infinity. I'll keep numerator as it is. In the denominator, let me take n cube as common term. Remember, you cannot take n as common term. Why? Because we have whole power 3. So, I have taken n cube as common. So, you will get 1 plus 1 by n whole cube. You cannot put cube again here. Why? Because you have already cube there. Fine. Now, n cube and n cube get cancelled. You will get limit n tending to infinity 1 divided by 1 plus 1 by n whole cube. Now, when you apply n is equal to infinity, 1 by infinity is 0. 0 plus 1 is 1. 1 cube is 1. 1 divided by 1 is 1. Therefore, the radius of convergence for the required problem is 1. Fine. So, its problems is very simple, but you need to understand the concept. So, whatever may be the problem given, I have tried my level better to solve more problems, but you have to practice the problems. Fine. Now, here is the 10th question. So, here clearly an is 2 power of n by n factorial. There is no particular method. As I said, we can use either the first method or the second method. But if it is solved, it cannot be solved in first method, you can choose the second method. Second formula. It depends on the problem. So, as much as problem you practice, you will get the method. Fine. So, an plus 1, I have replaced n with n plus 1. So, I have get an plus 1. Now, let me write the formula. R is equal to limit n tending to infinity an divided by an plus 1. Now, an is 2 power of n. I'll just write limit n tending to infinity. An is 2 power of n divided by n factorial. So, when you divide an plus 1, it will become reverse. That is n plus 1 factorial divided by 2 power of n plus 1. Now, let me write here limit n tending to infinity, and I am telling you once again, you have to write 1 by what I can say, that is step by step. You cannot write like this. Fine. So, 2 power of n by n factorial into n plus 1 factorial can be written as n plus 1 into n factorial. Again, 2 power of n plus 1 can be written as 2 power of n into 2 power of 1. Right. Now, n factorial, 2 power of n get cancelled. So, what you left with? Limit n tending to infinity, n plus 1 divided by 2. Now, let me apply the limit n tending to infinity. When you put, if you take n as common, then also you will get the same term. See here, let me take n as common. So, you will get this, right? So infinity, when you apply n is equal to infinity, infinity into anything will be infinity only. So radius of convergence is infinity for this particular problem. Clear? Now look at the 11th problem where we have z power of n factorial. In 10th problem and whatever the problems I have solved before, where you have z power of n, only n. But in the 11th problem, you can see that we have n factorial. So here the coefficient is nothing. So in the sense I can write this as an as 1 power of n factorial. In such case we have to write like this. Fine. Anyhow 1 power of n factorial will be 1 only. Then an plus 1 will be 1 power of n plus 1 factorial. So whatever may be the value raised to 1, you will get 1 only. Fine. And r is equal to, formula will be limit n tending to infinity an divided by an plus 1. Now an is 1, an plus 1 is 1. Right? You cannot write limit again. Why? Because it is independent of n. Therefore the required radius of convergence is 1. So here is the next problem. Here z power of n coefficient will be an as usual. So here comparing the standard form, z power of n is, that is an is equal to 2 power of n divided by n square. Fine. Now let me calculate an plus 1. Wherever n is there, you just replace it with n plus 1. 2 power of n plus 1 divided by n plus 1 whole square. Now let me write the formula. R is equal to limit n tending to infinity an divided by an plus 1. Now let me substitute. So limit n tending to infinity 2 power of n divided by n square. So when you divide it with n plus 1, I can write this as reciprocal, right? So if you want, you can write one more step also. 2 power of n plus 1. 2 power of n plus 1. Fine. Now let me simplify this. So I'll get limit n tending to infinity 2 power of n. Now n plus 1 whole square I have. So I can take n as common. N square as common. So first term I'll keep as it is, 2 power of n by n square. Now I'll take n square common. So you will get 1 plus n whole square divided by 2 power of n into 2 I can write. See, the procedure is same. The concept you have to understand. Either you can, as I already told you, it is just a general blind method. Usually when we have a z power of n's, we will go for second method, second formula. But we cannot say that is the particular formula. So as the problems, while solving the problems itself, you'll get an idea that which formula you have to use. Fine. So 2 power of n get cancelled and n square get cancelled. So what you left with as limit n tending to infinity 1 plus 1 by n whole square divided by 2. Now let me apply n is equal to infinity, that is limit. So you will get, when you apply n is equal to infinity, 1 by infinity is 0. So you will get 1 plus 0 divided by 2. That is 1 plus 0 whole square divided by 2. Anyhow it is 1 by 2. So therefore the radius of convergence for this problem is 1 by 2. Fine. Now let me solve one more problem. Here is the next problem. So this problem is quite different. Anyhow an, let me write an. An is 2 plus minus 1 power of n. Fine. So let me write down the formula. 1 by r is equal to limit n tending to infinity an power of 1 by n. Right? Why? Because I have powers of n. So let me write this as, let me solve by this formula. So I can write limit n tending to infinity. An is 2 plus minus 1 power of n whole power of n whole power 1 by n. Now n get cancelled. So you get n get cancels. So you get limit n tending to infinity 2 plus minus 1 power of n. Right? And now if you are going to put n as infinity, there will be two cases. Right? So you will get either 1 or 3. See here, when n is positive, that is what we say odd number, you will get even, that is 1 here. In the sense, suppose if the value of n is odd, you will get minus only, right? So 2 minus 1 will be 1. If n is even, you will get positive number. So you will get plus 1 here. Plus 1 plus 2 is 3. Clear? So 1 if n is odd. 3 if n is even. Fine. So n cannot be negative. right? So if you give n as odd number, you will get negative value here. So as radius of convergence is positive, we have to choose the positive value for this problem. So 1 by r is equal to 3, r will be equal to 3. This problem is quite different, where we have minus 1 power of n. If you give n value as odd number, you will get minus 1 here. If you give n value as even number, you will get plus 1 here. Fine. So since radius of convergence is positive, we have to choose even number. So that is why 1 by r is equal to 3. So if you get reciprocal of this, you will get radius of convergence as 3. Now let me solve one more problem. So this is 14th problem. Now in the previous hope so it is third or fourth problem, I cannot remember. You just go through the notes that you have already written now. So where I have taken only 2 into n factorial, right? 2 into n factorial, but here it is different. Here what I have 2n factorial, so it is quite different. So let me solve. Anyhow, an will be equal to n factorial whole square divided by 2n factorial. Now let me find the value of an plus 1. It is given by n plus 1 whole square, that is n plus 1 factorial whole square divided by 2 into n plus 1 factorial. Let me write this as n plus 1 factorial whole square divided by 2n plus 2 factorial it is. Fine. Now let me apply the formula. R is equal to limit n tending to infinity an divided by an plus 1. Now on substitution, what you are going to get? R as an is n factorial divided by, that is n factorial square divided by limit n tending to infinity 2n factorial into reciprocal. That is, when you are going to divide, you will get this term here. So instead of that, I am going to write it directly. 2n plus 2 factorial divided by n plus 1 factorial square. Now let me substitute. Simplify this. As I already told you, you have to elaborate the term. So n factorial, how can we elaborate? Instead of elaborating n factorial, it is better to elaborate 2n factorial. 2n factorial also, let me keep as it is. Why? Because always while elaborating, you have to elaborate the highest number, so that you are going to get in terms of lowest number. In the sense, if you are going to elaborate this term, that is 2n plus 2, next to this term, just decrease it by 1. Next to this term, just decrease it by 1. So you will get 2n factorial. Right? Next in the denominator also, decrease it by 1. You will get n factorial whole square. So I am going to split square itself. Now itself. So you will get this. Now 2n factorial, n factorial square get cancelled. So what you left with? R is equal to limit n tending to infinity 2n plus 2 into 2n plus 1 divided by n plus 1 whole square. Now let me take n as a common term in the numerator. So you will get 2 plus 2 by n common. So 2 plus 1 by n. So n square common, 1 plus 1 by n whole square. Now n square with these two terms get cancelled. So as you apply n tending to infinity, 1 by infinity is 0, again 1 by infinity is 0, again 1 by infinity is 0. So you will get 2 plus 0 is 2, 2 plus 0 is 2. That is 2 into 2 is 4. So as I already applied limit, so no need to put there again. So 4 divided by 1 by infinity is 0. That is 1 by infinity is 0 plus 1 is 1. So 4 divided by 1. Therefore the radius of convergence is 4. Only thing is, you have to apply the formula and take n as common term, apply the limit. Here is the next problem. So similarly, first write down an value, coefficient of z power of n square value. Right? So here an value is 2 power of n. Now it is just a different problem. See here, whenever you have z power of n, while using formula you have to write 1 by r as limit n tending to infinity an power of 1 by n. Right? Whenever you have z power n. Right? Similarly, whenever you have z power of n square, 1 by r will be changing to limit n tending to infinity an power of 1 by n square. Clear? You have to remember this key point. Why? Because in the given problem, that is in 15th problem, z power is n square. So in previous problem it is z power of n, that is why I have taken this. In this case it is n square, so you have to use this formula. Let me write formula here. 1 by r is equal to limit n tending to infinity an power 1 by n square. Now limit n tending to infinity, an is 2 power of n whole power 1 by n square. So square with this get cancelled. You will get limit n tending to infinity 2 power of 1 by n. Now when you apply limit n tending to infinity, 1 by infinity is 0. So 2 power of 0 is 1. That is 1 by r is equal to 1. Again if you take reciprocal, that is r value is 1. Fine. Now let us look at this problem. Here also it is quite different. Anyhow, let me write the value of an. It is 1 divided by 2 power of n into n cube. Let me calculate an plus 1 here. An plus 1 is 2 power of n plus 1 into n plus 1 whole cube. Fine. Since it is of the form z minus a, so no need to change anything. First formula will not change. So let me apply first formula. Limit n tending to infinity an by an plus 1. So limit n tending to infinity, substitution 1 divided by 2 power of n into n cube. So this will become reciprocal, 2 power of n plus 1 into n plus 1 whole cube divided by 1. Fine. Now 2 power of n plus 1, now I'll just rewrite this term. So 1 by 2 power of n into n cube. Now 2 power of n into 2 I can write. Now let me take n cube as common term. So you will get 1 plus 1 by n whole cube divided by 1. Now n cube and 2 power of n get cancelled. So what you get? Limit n tending to infinity 2 into 1 plus 1 by n whole cube. Now when you apply n tending to infinity, 1 by infinity will become 0. 0 plus 1 is 1. 1 cube is 1. So 1 into 2 is 2. Therefore the required radius of convergence is 2. Clear? So here is the next problem, 17th problem. So here an is 4 power of n into n divided by 3 power of n. An plus 1, you just change n to n plus 1. So you will get this. 4 power of n plus 1 into n plus 1 divided by 3 power of n plus 1. Now let me write the formula. R is equal to limit n tending to infinity an divided by an plus 1. So on substitution you will get limit n tending to infinity. An is 4 power of n into n divided by 3 power of n. An power of n, when you divide, I can write it as 3 power of n plus 1 divided by 4 power of n plus 1 into n plus 1. Fine. So limit n tending to infinity. Now let me write one more step. 4 power of n into n divided by 3 power of n. I can write this as 3 power of n into 3. Again denominator 4 power of n into 4. Now let me take n as common. So you will get 1 plus 1 by n. Now 3 power of n, 3 power of n, 4 power of n, 4 power of n, n get cancelled. So remaining limit n tending to infinity 3 by 4 times 1 plus 1 by n. Now when you apply limit n tending to infinity, 1 by infinity is 0. 0 plus 1 is 1. 1 into 4 is 4. So you will get 3 by 4. Therefore the required radius of convergence for this problem is 3 by 4. So here is the next problem. So this is quite different. Anyhow we have solved this kind of problem. So let me take an 2 plus minus 1 power of n whole power of n divided by 3 power of n. Now let us consider the formula 1 by r. Why? Because we have whole power of n. Limit n tending to infinity an whole power of 1 by n. Right? So limit n tending to infinity an is 2 plus minus 1 power of n divided by 3 power of n whole power of n 1 by n. Right? So I can write this as limit n tending to infinity. I'll just write it in one more step. 2 plus minus 1 power of n by 3 whole power of n whole power of 1 by n. Now you can cancel this. So I can write this as limit n tending to infinity 2 plus minus 1 power of n by 3. Now here also you can note that it depends on the value of n, whether it is even or odd. So as I already told you, suppose if n is odd, then you will get negative here. That is minus 1. 2 minus 1 is 1. That is 1 in the numerator divided by 3 if n is odd. Suppose if n is even, you will get positive here. So plus 1 plus 2 is 3. 3 by 3 is 1 if n is even. So as I already told you, whenever n is negative, since we are finding radius of convergence, it cannot be negative, so we have to choose the positive value. So this value will take positive only when n is even. So when n is even, it takes the value 1. Therefore radius of convergence, that is 1 by r is equal to 1, implies r is equal to 1. Here is the next problem. So here also you can note that z power is kn. So let me take first an. An is given by n plus 1 divided by n whole power of n square. Now let us write down the formula. 1 by r is equal to limit n tending to infinity an power 1 by n usually whenever you have z power of n, but here you have kn, so you have to write 1 divided by kn. That's all. Now let me substitute 1 by r is equal to limit n tending to infinity. An is n plus 1 divided by n whole power of n square whole power of 1 by kn. Now one term get cancelled. You will get limit n tending to infinity. Now let me take I'll just rewrite this term before taking the common term. So I can write this as n by k. Or else I can rearrange this as limit n tending to infinity. Now I can take n power of n, or else let me take n as common term inside the bracket. So you will get 1 plus 1 by n divided by n whole power of n by k. So n get cancelled. You will get limit n tending to infinity 1 plus 1 by n whole power of n whole power of 1 by k I can write. I'll just repeat once again. Inside the bracket I have taken n as common term in the numerator. So n get cancels there. You left with this. Now n by k is same as n whole power 1 by k. When you multiply you will get back the previous step. Now as you already know that in the note point I have given that limit n tending to infinity 1 plus 1 by n whole power of n is e. So this expression value is e. But we have power 1 by k. Right? So the value of 1 by r is e power of 1 by k. Therefore r is equal to 1 divided by e power of 1 by k. E power of 1 by k. So this is the required radius of convergence. So hope this concept is clear. So let us consider one more type of problem. Here the expansion is given and we asked us to prove, that is prove that this expression has unit radius of convergence, that is radius of convergence is equal to 1. So we need to prove this. First let me express the given expression as, I can write this in summation form, first term as it is. Why? Because we cannot write 1 in any of its nth term. So I can write this term as, see here in the first term what I have a. In the second term it is continued with a plus 1. Next it will be continued with a plus 2. So when you keep on continuing this you will get a plus n minus 1 for the nth term. So I can write this as a plus n minus 1 since I am writing nth term. Fine. In the second expression also first term is b, next term is b plus 1 continued with b, next term will be b plus 2. So when you keep on continuing you will get b plus n minus 1. So b plus n minus 1. In the denominator also 1 is there, next continue with 2, next continue with 3. So when you keep on continuing you will get n term. So that is n factorial. See here in the first term 1, in the second term it is 2 factorial, in the third term you will get 3 factorial. So likewise if you write it for nth term you will get n factorial. So in the c term, that is in the second term you have c, next c into c plus 1, next c into c plus 1, c plus 2. So if you continue you will get c plus n minus 1. So I have written nth term with z power of n. Fine. Now let me write this as a nth term, that is let me write an sequence an as z power of n coefficients. By neglecting 1 we can write an as a into a plus 1 into a plus 2 plus a plus 2 into so on a plus n minus 1 into b plus 1, so b plus 2, so on b plus n minus 1 divided by 1, 2, 3, so on n. Again c into c plus 1 into c plus 2, it will continue up to c plus n minus 1. So I have written only the nth term. Hope so it is clear. Right? Now let me write an plus 1. Wherever n is there, you just replace it with n plus 1. So n plus 1 term will be a plus 1, a plus 2, so on, a plus n minus 1 into a plus n. I have written just the previous term for this. See here, when you replace n to n plus 1 minus 1 get cancelled, you will get a plus n. So previous term for this will be the same. Right? So b into b plus 1, so on. When you write previous term, b plus n minus 1 into b plus n. I have written one previous term also. In the denominator, what you are going to get? 1, 2, 3, so on, n. So n is replacing with n plus 1. So previous term will be n. Similarly, c plus 1, c plus 2. So if you continue, last term is c plus n. So previous term will be c plus n minus 1, c plus n. Whatever, wherever n is there, replace it with n plus 1. Fine. You just write the previous term also. Previous term is same only. Fine. So I have written previous along with the previous term an and an plus 1 listed here. Now let us write down the formula. R is equal to limit n tending to infinity an divided by an plus 1. So if you divide, you will get limit n tending to infinity. So you can note that instead of writing all the terms, you can note that the terms up to here, that is a plus n minus 1, a plus n minus 1 get cancels. And in the term b also, all these terms will get cancels. Right? In the denominator, up to n will be cancelling. In c terms, up to c plus n minus 1 will be cancelling. Right? You should not mark all these things. I am explaining just for your reference. Fine. So after cancelling, what you're going to left with is n plus 1 in the denominator. So since you are shifting it after dividing, so n plus 1 goes to numerator into c plus n. So in the denominator, what you're going to get a plus n into b plus n. I'll just repeat this step once again. If you write this first and afterwards divide it with n plus 1. So when you divide, you will here also, here itself you can see the term, right? So it will get reciprocal. So whatever the terms you have here, that will comes to numerator. This term will comes to denominator. Moreover, no term will left here. So you should not cancel all these things. I have explained only for your reference. Clear? Now r is equal to, let me simplify this, limit n tending to infinity. I'll just take n as common term. So 1 plus 1 by n. Again n as common term. C by n plus 1. Again in the denominator n as common term. A plus 1 by n. N as common term. B by n plus 1. Here also a by n plus 1. I'm sorry. Am I correct? N as common term. So you will get this. Now let me apply n tending to infinity. This will goes to 0. Again this will goes to 0. This will goes to 0. And this will goes to 0. So what you left with? Limit n tending to infinity. So n into n is n square. So 1 plus 0 is 1. 1 plus 0 is 1. So n into n square is, n into n is n square. So it will get cancelled. You will get r as 1. So that is what we need to prove is. That is radius of convergence for this series is 1. Hence the proof. You have to write one statement. Since radius of convergence is 1, hence proved. Clear? If you want, you can write an and divide again with an minus 1. You can write one more step if you want. I have cancelled here itself and I have written directly. Since an plus 1 is left out in the numerator and b plus n is also left out. So I have written it in denominator and n plus 1 and c plus n in the denominator. So I have written it in numerator. Why? Because as you divide, it goes to numerator. Whatever the terms is there in numerator, it comes to denominator. In denominator terms goes to numerator. Fine. So let me solve one more problem. That is last problem based on the radius of convergence. So let me take the problem of this kind. So this will be the last problem on radius of convergence. So here we need to prove that radius of convergence of the given series is 3 by 2. Answer is given. We need to show that r is equal to 3 by 2. Fine. Here also first let me write the nth term. That is an will be z power of n coefficient, right? So I can write 1 since 3 is continuing, next 5 is continuing, so 7 will be continuous, so on. So when you simplify this, last term will be 2n minus 1, right? You apply the formula, that is a plus n minus 1 into dy, because it is in geometric series, right? So you will get 2n minus 1. In the denominator 2, 5, 8. So if you continue, you will get 3n minus 1, nth term. Fine. Give value for n is equal to 1. So you will get 2 into 1 is 2, 2 minus 1 is 1. Give n is equal to 2, you will get 3. N is equal to 3, you will get 5. So this is the nth term. Fine, now let me write an plus 1. An plus 1 will be replace n with n plus 1. So before replacing, I'll just write here, replace n with n plus 1. So I'll simplify here, n plus 1 minus 1. You will get 2n plus 2 minus 1. So 2n plus 1. After replacing n with n plus 1, you will get 2n plus 1. I'll just write the term previous to this. This will be 2n minus 1. Fine. Next, in the denominator 2, 5, 8. Similarly, you will get previous term 3n minus 1. Here 3n minus 1, right? N is replacing with n plus 1 minus 1. 3n plus 3 minus 1. So 3n, 3 minus 1 is 2. So you will get 3n plus 2. Fine. Now let me write down the formula. R is equal to limit n tending to infinity an by an plus 1. So here also if you want you can write one more step. In this problem I'll write the steps. See here, an is 1, 3, 5, 7, 2n minus 1. Limit n tending to infinity r is equal to 2n minus 1 into 2n minus 1 only, an I am writing, divided by 2, 5, 8, 3n minus 1 into, since you are dividing, so it will goes to numerator, 2, 5, 8, 3n minus 1 into 3n plus 2, divided by, this comes to denominator 1, 3, 5, 7 up to so on, 2n minus 1 into 2n plus 1. Fine. So terms up to here and up to here get cancelled. Again these terms get cancelled. So what you left with, r is equal to limit n tending to infinity 3n plus 2 divided by 2n plus 1. Fine. So r is equal to limit n tending to infinity. Let me take n as common term. So you will get 3 plus 2 by n. In the denominator also n as common term. So 2 plus 1 by n. So when you apply n is tending to infinity, n get cancelled. As n tending to infinity, 2 by infinity goes to 0. Again 1 by infinity goes to 0. So therefore, if you want, I can just write one more step. You will get 3 plus 0 divided by 2 plus 0. Therefore, the required radius of convergence is 3 by 2. And that is what we require to prove is. That is, radius of convergence of this series is 3 by 2. Hence, proof. So this completes the problems on radius of convergence. Please practice these problems. And once again I am telling you, we cannot predict the particular formula for the particular problem. So more the problems you practice, more the idea you will get. Hope so all the concepts regarding the radius of convergence is clear. So continue in the next session. Please write down again, the notes of this concept will not be sent in the group. You have to you have to solve these problems by watching the video. Hope so you will do this. Thank you.